Floating point numbers and rounding. In this video, we will learn how to safely compare floating point numbers. Consider the following program. Suppose I declare a variable named x and set it equal to 10. Then in the if statement, I compare it to 10, saying if the variable is equal to 10, print equal, else print not equal. Obviously, if I were to execute this code, equal would be my output since 10 is obviously equal to 10. However, now consider this program. Suppose I declare a variable x and set it equal to the results of an expression, 0.0037 divided by 100. Then in an if statement, I compare that variable to 0.000037, and if they're equal, I'll print out equal, otherwise print not equal. Now, on face value, I would think the program would print out equal since when I type the initial expression into a calculator, 0.000037 is what I get. However, for some reason, when I run the program, I get not equal, meaning it's telling me that x is not equal to that number. Why is that? Moreover, if I were to add a line to this code saying, hey, print the value of x, this would be my output. Currently, the number is written in scientific notation. Here's how the number would look if it was not written in scientific notation. As you can see, there's a very tiny difference between the value that actually got stored in x versus the value that we expected to get stored in x. This is a very common occurrence when dealing with extremely small floating point values. Now, just out of curiosity, what if there was a way to tell our program to only focus on the first 20 decimal places of x rather than the entire value of x? If that were a possibility, then our program would produce the correct output. We would get equal because the 5 at the very end would get ignored, and it's the 5 that's throwing off our program. Fortunately, Python does provide a way to round x to the first 20 decimal places. It's called the round method. Here in the example here, we call the round method and give it two values. We give it x, the number we want rounded, and 20, the number of decimal places we want it rounded to. When we execute this program, we get equal because the 5 that was throwing off the comparison in the last program is now getting ignored in this program. Okay. In general, there are two ways to use the round method. The first way is by giving it two values, where the first value must be a number or an expression that evaluates to a number, and the second value must be an integer, because that second value is going to be the number of decimal places that the first number will get rounded to. And on the far right, you see an example of this taking place. The other way to use the round method is to give it just one value, which in that case, that value will simply get rounded to the nearest whole number. Now, you may be wondering, if we use the round method whenever we compare floats, wouldn't that decrease the accuracy of our programs? And to that, I would say not necessarily, because in the real world, we usually only care about the first few decimal places. Very rarely do we care about the numbers beyond that. For example, at a retail store, when we compute sales tax, we take the price, multiply it times 0.825, then round that result to two decimal places before computing the total price. For many real-world applications, just like with sales tax, we typically only care about the first few decimal places. We don't care about the 10th, 11th, or 12th decimal place, which is typically where these computation errors tend to occur. So if you're going to be comparing floating values and you know you're going to be working with numbers that have a lot of decimal places, it's typically safer to just round them and use the rounded result rather than count on Python to compute a 100% accurate calculation.